sharing the Minitab screen. So there are two parts here. Then when you see this area is known as worksheet. This area is known as worksheet. Let me type it here for you. Worksheet. Hope all of you can see my word worksheet, right? So
Yes, sir.
this area, which looks like the Excel sheet, is known as worksheet. Here you can copy paste your data, or you can type your data. Like say, no, I am typing my data. The data header and then some data, 2, 3, 4, 5, whatever. So some data, you can type it here. And then this area is known as session window. This area is known as session window. So in this session window, all your reports will come. Whatever analysis you do, the report will come. Clear now? There are two parts. One is worksheet. The other one is session window. And Minitab contains tabs here. There are two important tabs I want you to know, understand and be comfortable using. One is stat, where you see a lot of statistical tools and QC tools. And similarly here, the graph, so many graphs. So these two areas we are going to understand now. All right. So now, all of you please tell me, first of all, what is statistics? Any idea? What is statistics? Statistics means it's a science of, you know,
Numbers,
collecting data.
collecting data.
Yeah, science of collecting data. And then you have to present your data in some format, isn't it? So in Excel, we plot the data in different columns. So we collect data, present data, and then we analyze it. I mean, before that, we visualize it, and then we analyze it, and then we, whatever analysis result is, we interpret it to understand its meaning. So the whole set of activities is known as statistics. Clear. So is it clear? Statistics means a science
Science of
of
collecting
collecting,
data.
tabulating, visualizing, analyzing, and then interpreting the data. Data is giving you some useful information. That information you need to understand. For whatever needed, you do. Starting from the collection of data and interpreting the data, all that you do is a science, which we call it as statistics. Clear, all of you? Yes. And
Yes, sir.
now there are two types of statistics. One is known as descriptive. Another one is known as inferential. One is known as descriptive. Another one is known as inferential. So your descriptive is nothing but you are understanding the present and the past or the known things. Whatever is known, you are just verifying it with the help of data. Let's say how many people are now attending the session right now. That's a
Seven,
statistics.
seven.
7 people are attending this session. So that is a statistics. And maybe next online session, next Thursday session, how many people will attend? So right now, how many attending? 7. But now I'm worried about how many people will attend next week. When I think about the future, then it is known as inferential. This is unknown. In order to predict the future, again we use some data only. This week 7 people attended, and next week, and there were some rain this week. Probably next week, I think the count can be more, isn't it? We are expecting more. So that is inferential. So you use the data to understand the present. Sometimes you use the data to understand the present or to understand the past, or you just use data to understand what's exactly happening in the current process, the known things, right? So this is known as statistics. And but inferential means again we use data, but this time we want to understand, or we want to predict the future. That means the purpose is prediction. Earlier, the purpose is just understand, verify. We have some understanding. We want to have deeper understanding. We want to get it verified. So we collect data and then Get it done. That's descriptive. But now we want to predict what will happen. If this is how the process is running, what will be the rejection percentage? What will be the cost of poor quality? Or what will be the expected sales next quarter? So these are all called inferential statistics. Hope all of you understand what is descriptive and what is inferential.
Inferential.
Correct? In 31 World Cup matches played by Virat Kohli, his batting average is 58.5. What is this? Is it descriptive or inferential?
Descriptive.
Descriptive. He has already played. And next World Cup, what could be, or what will be the batting average for Virat Kohli?
Inferential.
Inferential. Maybe you might expect, more average. Or you might think that, his age is now increasing. Probably his batting average might drop, whatever it is. But you use the current performance and also apply your common sense and you predict the future. Then it is inferential. Do you think these kind of decision makings will be helpful in your business also, in your current role also?
Yes.
Yes or no? Yeah.
Yes.
So why we use data? We use data to understand our confidence level. To understand our confidence level while making a decision. While making a decision. Our confidence level. Normally 95% confidence level is required. This is industry practice. Normally, any conclusion I make, I have to achieve at least a confidence level of 95%. This is the reason why we use statistics. This is the reason why we use data. When I say confidence level, what does it mean? Whatever I say
Has to happen.
has to be,
Has to happen.
has to happen. At least 95% of the time. At least 95% of the time, isn't it? If the same experiment is repeated 100 times, at least 95 times, whatever is your observation, that should happen.
It should happen. Yes.
But 5% of the time, maybe for some reasons, because certain things we can't predict, 5% of the time, it can be a different conclusion. This is called a 95% confidence level. All of you are with me?
Yes.
Yeah. So I want to say that the pass percentage is always 100% in our black belt examination. The pass percentage is, expected pass percentage is how much?
100%.
100%. And now I'm also telling that, yes, I'm 95% confident. That means if I run 100 batches, at least 95 batches, the pass percentage is how much? 100%. But in 5 batches, things can go beyond our control, yes or no?
Yes.
So this is the meaning of confidence level. Always, any decision you make, you should be able to make it with the 95% confidence. Then you are a very good decision maker. Because at least 95% of the time, your decisions are correct. People will love the way you are taking decision. They'll start seeing you as a leader. Yes or no?
Yes.
Yes. And now you also need to understand one more thing, which is known as confidence limits. Which is known as confidence limits. Just now we spoke about Virat Kohli. Let's not worry about World Cup. Let's worry only about the one-day international. In one-day international matches, Virat Kohli's batting average is how much?
100.
Shall we take it as 55?
Yes.
55%. 55 runs. So suppose Virat Kohli plays one more series. What will be his batting average? Let's say one more series of a series containing let's say some 7 matches. What will be his batting average? Will it be exactly 55?
60, 58 somewhere.
Yeah. It will be the predicted average. Right? We are now trying to predict the average. The predicted average is 55 plus or minus. Can I say 5 runs?
Yes.
Yes or no? 55 plus or minus 5 runs. Now you expect Virat Kohli to score between to maintain his average between 50 to 60.
Yes.
50 to 60.
60.
Now the 50 is known as LCL. But this time the meaning of LCL is lower confidence limits, lower confidence limit. This is not lower control limit. Please don't confuse. What did I say now? The 95% lower confidence limit. Symbol wise, it is same LCL, but it is lower confidence limit 50. And now please tell me, what will be the upper confidence limit?
60.
What will be? Very good. 60 is the upper confidence limit, 50 is the lower confidence limit. Now we are not able to predict accurately. We are not able to predict accurately. And what is the expected error? What is the expected error? Plus or minus?
Plus or minus 5.
5 runs. That 5 runs is known as margin of error. This 5 run is known as margin of error. All of you, can you see that?
Hmm.
You want the margin of error to be minimum or maximum?
Minimum.
Minimum. That is the challenge in statistics. Please understand. That is the challenge in statistics. We want to predict or we want to decide with the 95% confidence level. At the same time, the margin of error has to be minimum. That means the distance between lower confidence limit and upper confidence limit should be as minimum as possible. That's why we need statistics. Hope all of you agree with me on this. Now I want to predict your marks. And I'm saying that all of you will score marks between 0 to 100. This is a good prediction. Yes or no? All your
No.
marks are expected to be.
No.
Nobody will appreciate this. Nobody will appreciate this, decision or prediction. Because why? Because the range is too much.
Too much.
Isn't it?
Yes.
And now you are 100% confident. But the challenge in decision making is achieving 95% confidence or 99% confidence or 90% confidence according to the requirement, according to the criticality of the decision, but with the error should be minimum. Yes or no? The error must be minimum. So that's why we work with data. That's why we try to work with accuracy of data, isn't it? Data accuracy is very important, yes or no?
Yes.
And data accuracy will get affected mainly if there is measurement error. We are going to learn it in the day number 3 coming Saturday. So measurement error is a killer of data accuracy. If you commit the error, then what will happen? All the data will have error. Then your statistics will also have error. Your upper confidence limit will be located wrongly, lower confidence limit will also be located wrongly, and your average calculated will also be wrong, and your decision will not be appreciated. Right? To avoid that, one is this thing. Another thing is data accuracy, and another thing is the source of the data. Right? The source. What do we call it as? The sample. And if you don't know how to take the sample, then you will definitely be committing another error known as sampling error. Both of this can affect your decision, can affect your confidence limit. Hope both of you agree with, all of you agree with me. So we need to be very, very careful in getting a quality data so that we can take proper decision. Very good. Now let us take some data. So I just want to go to stat, basic stat. See here, descriptive statistics. You all know the meaning of descriptive statistics. Can somebody read up the description here? What is
Summarize the
descriptive
data
Summarize
with
shown
descriptive
data.
research of the mean and the standard deviation and display the result in session window.
Very good. So they have given only an example, mean and standard deviation. So let me get some data for you. Maybe I go to help. And I go to help. Are you able to see the help window also?
Yes, yes.
Very good. So then the example. Some example here. Data is pulse.mtw. So I'll open it for you. Don't worry. So we just cancel this. Go to file. Open worksheet. And there is sample data folder. I just click this. And now something known as pulse. You can now see pulse.mtw. Pulse data is available. I just open it, give OK. Can you see some data coming here? Right? Pulse 1, pulse 2. How many pulses are available? Near about 76
91.
data. Can you see that, all of you?
Yeah.
Yes.
Yeah. So how the pulse is? Suppose if the pulse data is about some individual whom you are interested in, and now would you like to understand the statistics? What is the average pulse? Very important, isn't it?
Mm.
What will be the lowest pulse? What is the highest pulse? If with the help of some statistics, you can understand the person's health in terms of the pulse rate. Yes or no? We know the normal pulse
Mm.
rate ranges. Let's
Yes.
try to do some analysis. I mean, some calculations. Anything you calculate, that is known as statistics. So I click stat, I click basic stat, I click display descriptive statistics. And for what is the data for which you need statistics? Column. So I click and select. Now I click the statistics. Can you see so much statistics come here? Now let me uncheck first. Uncheck everything. Mean. The first one is mean. All of you, do you know what is mean?
Yeah.
Mean
Average.
Yeah.
is average, right? Mean is average. Then standard error of mean. Standard error of mean.
The decimals, whatever.
Helps. Standard error of mean helps in locating your confidence limit. Helps in locating your confidence limit. If the error is, I told you margin of error, isn't it? So standard error of mean actually a form of error which decides your confidence limit. More the error, farther will be the confidence limit, which is not good, too good for your decision making, isn't it? So I just, time being, I leave it. Standard deviation. All of you should be knowing standard deviation. Variance. What is variance? Tell me what is
Difference.
variance.
Difference.
No. Variance means variation. We discussed in the day number 2.
Yes. Yes.
Tell me then. Then it was discussed. We spent time already. What is variance?
Sir, variation from the mean.
Very good. Nice answer. Smart answer. Variation from the mean. Variation from the mean can be called as standard deviation, can also be called as standard variance. But what is variance? Variance is square of the standard deviation. Variance is square of the standard deviation, isn't it? That means standard
Yes.
deviation is square root of the variance. In either way, you can tell. And now there is something called coefficient of variance we have not discussed. So sum means all of you know the total of the readings. Minimum you all know, maximum you all know, range you all know. All right. Total n means number of samples. Any particular day you have not taken the sample, that also will be indicated. If you have taken sample on all the day, then no missing. Cumulative n and first quartile, median, third quartile. What is median? Any idea what is median? If you arrange the data in increasing order or decreasing order, when you arrange the data in increasing or decreasing order, what is
Mid
the
value.
data? What is the data that can divide your data equally? Or what is the point
Mid
that can
value.
divide your data perfectly equal? That is known
Mid value.
as
Median.
mid value. We don't call it mid value, we call it median. Clear? All of you are with me? We call it median. Agreed?
Sir, what is n, sir? Actually,
N means number of data. N means number of data. You see here this one, right? N total.
yes, sir. That one. Okay, sir. Okay.
You don't have to scroll down. You don't have to scroll down to understand how many. The Minitab itself will tell you. Clear?
Okay, sir. Okay.
Right. So median, I told you. Median means it divides the data into 2 equal parts. Clear?
Mm.
Suppose I divide the data partially, 25% to one side and 75% to other side. I mean 25% to the left side and 75% to the right side. Then the point is known as first quartile. Then clear? Then the point is known as first
First
quartile.
quartile.
Suppose if I
75 to
it 75% on the left side and 25% on the right side, then the point that is dividing in that manner is known as third quartile. Clear?
What is the use
Okay.
of those?
What is the use? We will calculate and then I'll come to that, right? And then interquartile. Interquartile range means the distance between your third quartile and first quartile. The distance between your third quartile and first quartile. See, you can understand where your readings are, accumulated, where the density of the readings are more and where the density of the readings are less. Some information, isn't it? Whether in the first quartile, too many data points are there, or too much data are there in the interquartile range, or is that too much data are there in your fourth quartile, you can understand, right? So that's the thing. And mode means the most frequently occurred data. I think this much statistics, we are very, very clear. Gradually, we need to feel comfortable with all the statistics. Right now, I'm going to give okay, so that Minitab can generate the report for us. Again, okay. And now, can all of you see the results here? Very easy job, right?
Mhm.
Come on, confirm.
Variable
And
pulse.
now what?
total-
Variable is pulse. What is the total? What is this n? Somebody asked, right?
Number of readings
That
count.
means number of
Occurrence.
sample is 92. 92 readings you have taken. None of the row
Missing.
is blank. Every row you have a data. No,
Failed.
no sampling is done on all the 92 days. So what is the average pulse of that particular individual?
72.
72.87.
If this average is in the normal range, you should be happy, isn't it?
Hmm.
Yes.
We normally expect the pulse to be, let's say in the range of
70.
60 to 90. And then it is 72.87 is proper. 60 to 90 is the normal pulse and your reading is 72. That means it's okay. But if
Okay.
the average is on the higher side or average is on the lower side, then you should be worried. Correct?
Yeah.
All right.
Hmm.
And standard deviation is 11. That means 11 seems to be on the higher side and there is a lot of variation in the pulse. You can understand, right? And variance. Can you see this variance as a squared value of this 11?
121.
Square value of 11.
Sum means total added together, all the numbers added together. And what is the minimum pulse on a particular day? The lowest
48.
pulse
48.
recorded is how much?
48.
48. Do you understand anything out of it?
The day pulse is less. It is watch out.
That day the pulse is too low. Maybe that particular day needs attention, needs some investigation. What went wrong on the day, isn't it?
Hmm.
Yes.
Similarly, one particular day the pulse rate was
Too high.
maximum 100. So that also might require. This is how you need to use statistics. Right? And then the median pulse is also 71. That means more or less normal. If the average and median are same, more or less normal. And look at your quartile 1. What does it mean? At least, 25% of the time, 25% of the time, your data is lesser than quartile 1, 64. Can you see that? Because below quartile 1, how much percentage of the data will be there? 25%.
25%.
25% of the time, your pulse rate is less than 64. Similarly, another 25% of the time, your pulse rate is more than 80. But 50% of the time, the pulse rate is between 64 and 80. Can you understand all this statement?
Yeah.
Do you now understand the purpose of all these statistics?
Yes.
Madam, you have to answer. You only ask the
Yes.
question.
Yes.
How to use coil? Now I am giving an example. Yeah. Now,
Sir,
what percentage of
I'm not able to
data?
understand that, sir. That quartile and that number, sir. I'm not able to relate to that.
Mhm. That's why quartile 1 means I told you clearly. Quartile 1 means it's a point that will divide your data. 25% of your data will be to the left of quartile 1. 75% of your data will be to the right of quartile 1. So that particular point, what we call it as, maybe I will visualize, then you will be able to understand, right? I'll plot a graph, then you understand. And now range. What
That
is
will be
range?
better.
Can somebody tell me what is range here?
Range is
What is
50.
range?
What is this range?
Did Q3 and QN difference between? No.
You have not understood. You have not followed. You're on mute. Krishnan on mute.
100 minus 48, maximum minus minimum.
Maximum minus minimum. That is the definition for range. If you find out the difference between Q3 and Q1, that is known as interquartile range. Madam, that is interquartile range.
Okay.
Q3 minus Q1 is IQR. But maximum minus minimum is R. With most of the day, the pulse is recorded as 68. Can you see that? Most of the time your reading is 68. That is mode. How many times that occurred?
11 times.
Ah, do you understand? This is descriptive statistics. Agree, all of you?
Yes.
Helping you to understand what's happening with respect to the pulse rate?
Yeah.
The data can be pulse rate, data can be the characteristics of your product, or data can be your performance measure. All of you. Now,
Yes,
will
sir.
you be able to comment about your team's performance if you have a proper statistics like this?
Yes.
50% of the time my team is performing in this range. 25% of the time my team's performance is extraordinary. 75% of the time my team's performance is in this range. All of this statement you can make yourself. All right. Perfect. And now, since I think Divakar asked about Q1 and Q3, let me show him some graph. Graph. There is something known as box plot. Can you see, all of you?
Hmm.
Can you please read the description? Maybe Divakar, can you read it?
Examine the center and spread of your data by plotting the median, the quartiles, and the outliners. Works best with samples of at least moderate size. N is greater than 20.
N is greater than 20. If you have more than 20 data points, then the box plot works best. We have about 92 data points. So let's go for it. Box plot. A simple box plot. I choose, I give OK. And now which is your variable? Pulse, which is typed in column number 1. Click and select. All right. And then you just go for OK. Divakar, can you see the box plot now?
Yes, sir.
Can you see the box plot? And see, there is a first line, no? Can you see this line? How much is this value? Near about 60,
That was
64 or
64, I
65.
guess. Yes, sir.
Yeah, this line represents your quartile 1. 64, you can also see that. It's coming, isn't it? 64. This
Hmm.
is Q1. And this line, center line, this line is median. And this line is, and height of the line represents your area below Q1. What percentage of the data will be below your Q1? 25% approximately. All right, 25% of your data is expected to be below Q1. Similarly, upper 25% of your data is above Q3. Now this blue color region is the interquartile range. Now tell me, the spread is more in Q1, Q2, Q3 or Q4? Where is the spread more?
Q3.
4.
Q4.
Q4, sir.
Q4, sorry,
Q4
sorry.
probably. Q4 the spread is more, but between Q2 and Q3, Q3 is more.
Right.
So if you want to improve the consistency in the performance, probably you need to work here first. Isn't it? So this is called what? What is this graph? Box
plot.
plot. Box plot. So this bottom line and this line are known as whiskers. This is known as whisker, not whiskey. This is whisker, right? You have one whisker here and another whisker here and this blue color region. And now let's plot another graph to visualize the same thing. Graph, I go to histogram now. I go to histogram. Now simple histogram, okay, and choose the same thing. And now you give okay. And now all of you use your eyes. Use your eyes and tell me, is it looking like a bell curve? More or less. Is it looking like a bell curve?
Almost,
Sort
yes.
of, sir.
Almost. Very good. And now it's not a perfect bell curve simply because you don't have sufficient amount of data. Always, more the sample, the perfect will be the bell curve. If you expect a more perfect bell curve here, then what should you do? Instead of just going with 90 data points, probably you go with 900 data points. You will see a smooth bell curve. But the challenge is, most of the time, the challenge in our work is, we don't have time to collect so much data. Yes or no?
Yes.
Hmm.
So how can we predict? How can we make better prediction with lesser amount of sample? That means you all should be an expert in inferential statistics. Use minimum of data and make your predictions as accurate as possible. That is a challenge. Otherwise, you can simply wait for a longer time and then you can take an accurate decision, but nobody will be there to appreciate you because you have taken so much time. Isn't it? After the match is over, it is very easy to announce which team has won.
Right.
Isn't it? So you have to predict early and using minimum of data because the cost of collecting data, effort, and everything is high. That's the challenge. Otherwise, the simple thumb rule is more is better. More the data, better will be the prediction. And now, with the help of the histogram, will you be able to understand something? Where is your data clustered? Can you see here? Where is your data clustered? Majority of the data around this 65 or 70, isn't it? Yes or no?
Yeah.
That's why the mean is, you said the mean is 71 or something. The mean was 71. So most of your data points are clustered. As you move away from the mean, the frequencies are reducing. You see that? Only a very smaller number of days, maybe for 1 or 2 days, the pulse rate was around 100. Similarly, just for one day, the pulse rate was around 50 or something. Hope all of you understand. This is what we studied in normal distribution. I have demonstrated, isn't it? All right. So maybe one more way of doing the same thing. Stat, basic stat, display descriptive statistics. Display descriptive statistics. And this time again, the same data. I just give okay. Oh, sorry. Display stat, basic stat, graphical summary. Go for a graphical summary. Stat, basic stat, and then graphical summary. And now you choose the variable that you want to visualize. Give okay. Can you see the bell curve? They approximately shown the profile also. And you can see some statistics here, mean, standard deviation, variance, etc. etc. Clear all of you?
Hmm.
See here, 95% confidence interval, 95% confidence interval for mean, 95% confidence interval for median. Why this confidence interval comes into picture now? You have a mean, but why confidence interval? Can somebody answer this? You have a mean. It doesn't mean that always the mean will be this. Am I correct? Come on, yeah, you all should communicate. Have a conversation. See, the mean is, how much is the mean? How much is the mean here?
71.
72.87.
72.
72.8.
Does it mean every time you will get? Yeah. Does it mean every time you will get 72.87?
No.
If I
No.
take another round of 100 reading, will my mean be the same? No.
No.
It
No.
will be in an interval, and that interval, can you see here? That interval, can you see here?
Uh-huh.
What do you see?
70.590.
70.59?
75.
Ah. If I take another 100 readings, my mean will not be exactly 72.87, but at least it will be in this range.
Okay.
Actually, I'm taking the reading only once a day. But next take is by me. If they take their mean, oh sorry, their mean will be in this range. What is the range? 70 to 75. All of you understand how the
Ah,
statistics is helping us? Do you understand?
yes.
Mm-hmm.
And in order to calculate this interval, yes, yeah, statistics is helping us. That statistics is nothing but standard error of mean. That statistics is nothing but standard error of mean. I'll tell you now. Can you see here something, when we actually calculated initially? Where is that? Here. Oh, mean, standard deviation. Oh, standard error is not listed. No, we
So we
missed it.
didn't take
Okay,
it,
don't
sir.
worry. Yeah, we didn't take it. That's why it didn't come. No problem. I will tell you now. Standard error is equal to standard deviation of the sample divided by square root of sample size. Very simple. All of you understand this equation? What is written here? What is written here? Standard deviation of the
Sample divided by
Sample.
square root of the sample size.
divided by square root of the sample size.
Sample size.
So now the standard error is available. Now, see here, your confidence limits. Your confidence limits, approximate formula I'm giving. Later on, I will give perfect formula. So mean plus or minus 2 times standard error of mean.
Okay.
Confidence limits is equal to mean, whatever mean you calculate, plus or minus 2 times standard error of mean. Now, we all studied normal distribution last Sunday afternoon, isn't it? Normal distribution. What are the properties you remember? Normal distribution, some properties we discussed. What is the first property?
Symmetrical about the average, the mean.
Symmetrical about mean or average. Then mean equal to median equal to mode.
Mode.
Sir, no?
Yes.
All of these things will happen to your population. Please note. All of these things will happen to your population, provided your population data is a biological data. Means your process is normal. If your process is normal, the data will exhibit normality. All of you are normal now, right? Most of the process run in a normal fashion only, unless it is, influenced to behave differently. It will behave as a normal distribution only. All right. So mean equal to median equal to mode, and then 68.27% of the data points are expected to lie
Between 1
between
sigma
Between-
level.
Between
Between
plus
1
or
sigma
minus
level.
1 sigma.
mean
Plus
plus or minus
minus
1
1
sigma. Plus or minus 1 sigma. What is sigma? Standard deviation
standard
of the data.
deviation.
Standard deviation of the data. Now, 95.45% of the data points are expected to lie
2 sigma.
between mean plus or minus 2
2
sigma.
sigma.
Now the third, another point. What is
99.73.
that point?
99.73.
Very good.
99.73.
Very good. 99.73% of the data points are expected to lie between plus or minus 3 sigma. See here, I said data points, isn't it? Now, I'm going to give you one more set of rule. See here, 68.2% of the times your average is expected to lie between mean plus or minus 1 time standard error of mean. Do you understand the difference now? Difficult to digest, but still you must try to understand. Earlier, what is that earlier I have written? 68.27% of data points. Data points means any single value, isn't it? Data points means any single value, any data you take that is expected to be between mean plus or minus 1 sigma. But now, what is that I have written? Instead of single data, what is that I have written here?
Your average.
Your average.
There is a difference now. This time you are not going with one sample, you are going with multiple sample. You are going with
Multiple samples.
multiple sample, maybe 3 sample, 5 sample, depending on your capacity. If you are very rich, you will go for more sample. If you are a very poor guy, you will go with 2 sample, 3 samples, isn't it? So it is always, more is better. Let's say you have taken 10 sample. Now, can you calculate an average using the 10 samples? Yes or no? You can calculate.
Yes, we can calculate.
That average is expected within mean plus or minus standard error of the mean. Standard error of the mean, we have understood already. It is not just standard deviation. It is standard deviation divided by, come on, tell me, standard deviation divided by
Square root,
Square root of
n.
sample size.
Square root of sample size, which is n. So whenever you want to predict the average, use standard error. Whenever you want to predict a single observation, use standard deviation. Can you understand, all of you?
Can you tell that again, sir?
Can you repeat, sir?
I want to predict the mark scored by Krishnan in our upcoming exam. Of course, I have some track record, some past exam I have, some sample I have. Now I want to predict an individual score, which is difficult, isn't it? Which is a tough job. Now another situation is, instead of predicting one individual's score, I will try to predict the class average. Where the prediction can be better?
Class average.
Class average.
Class average. That is why you must always base your decision using average, not on the individual observation. All of you are with me? Even though you base your decision on the average, still there will be some amount of error. In order to understand your margin of error, you need to use standard error. I have given the formula for that. What is the formula? Standard deviation divided by square root
Square root
of
of the sample size.
Let's keep it in mind. At some point of time, all of this information will be extremely helpful. You will start understanding, all the languages used by statistician. Otherwise, what happens? You will feel isolated. All right. And now only change you need to do is, instead of saying the data point, you say average.
Average.
And then instead of sigma, you have to say
Standard
error. Very good. When I say plus or minus 2, you see the percentage is 95.45. You can see that on the left side. So in order to make it exactly 95%, what we do is, I just copy this to make it 95%. I just frame another statement. 90, instead of 95.45, I want to make it 95. So what will happen? This 2 will slightly get adjusted. 1.96. When I make it 1.96, I get my 95% confidence limits. Same thing is applicable here also. Here also it is applicable. See, I want exactly 95% confidence limit. 95% of the time, the average is expected to lie between plus or minus 1.96 times the standard error of the mean. Hope you have understood something now. Can somebody summarize what is that you understood now, so that we can move on? We learned something here. Nothing but we recalled our understanding on the normal distribution. And once you are feeling comfortable with the normal distribution property, you can make meaningful decisions. You can start making predictions. All right. So what I do is, Now come here. See here. The same pulse rate, pulse rate. What is the mean and standard deviation? Please remember. Mean pulse rate is how much? 72.87.
87.
All of you, please,
Hmm.
please note this. I will be asking you have to tell me. And then standard deviation is 11.01. Now I want you to take to a graph, probability distribution plot, right? And view probability. Okay. And now the distribution I want to follow is normal. What is the average pulse rate? 72 point.
72.87.
It's
Very
87.
good. 72.87. And what is the standard deviation you observed?
11.91.
11.01.
11.01. Now I want to see what will be the population. What will be the population having a mean of 72 and standard deviation of 11. And now I want to go to, let's say, shaded area. Go to shaded area. Let me understand. Let me give the probability. Probability, I'm giving how much? 99.73. You all know why I'm giving 99.73.
Hmm.
99.73 means plus or minus 3 standard deviation, isn't it?
3 standard deviation. Yes.
I am simply typing this 99.73 and now I want to find out the area between yeah. So this area, I want this area to be 99.73. I choose this. Oh, sorry. Uh, which is selected here. Okay, probability 99.73, left tile, right tile, both tile, middle. The following is too large. Please specify a single. Oh, sorry, correct. I cannot say 99.73 in this manner. I have to say 0.9973.
Acha.
So just to know the format 0.9973. I want to see the area. No, 99.73. So I choose this. Maybe which one I should choose? Okay, this one I will choose. So both side equally divided. Like perfectly, right? I selected both tile. I give OK. And now all of you can see the distance. What is the mean? 72.87.
Uh-huh.
What is the see almost entire curve is now shaded. Why so much is shaded? Because very small percentage is available on the right and left. Let me reduce it. Graph, probability distribution plot, view probability. Okay. Same thing, shaded area. Instead of this thing, I want to say 68.27. I am typing 0.6827. Let me give OK. Now, oh God, now this is right and left. Let me make it a little different. Probability distribution plot, view probability. Okay. I want the area inside. Inside means this is outside, this is inside. Why two different probability? Okay. Anyway, no problem. Let us take two side. So I want half of 68.27 is, let's say 34.135. Left side probability and same thing, right side probability. I'm just trying to visualize the same property. Now, what do you see here, all of you? This area accounts to how much?
Very small area.
Oh, small area. Oh, 34%. This side has come 34. No, this is 31%. Graph, probability distribution plot, view probability. Okay. Mean standard deviation declared. Standard area. Okay. Let me go like this. Let me give the X value. So X value, uh, uh, two values. Very good. Now, please tell me. All of you have the mean and standard deviation, right?
Hmm.
Please tell me what is mean minus one standard deviation. Mean minus 1 standard deviation.
One standard deviation.
Yeah, standard deviation is 11.01. So
Yes.
subtract 11.01 from the mean. How much it is?
61.86.
Okay, 6186. I have typed this. Now similarly, mean plus 11.01. That is how much?
83.88.
Very good. Now you all know the meaning, right?
Mhm.
Mean plus or minus 1 sigma I have given.
Mm.
What is the area expected inside? 68.27.
Mhm.
Yes or no?
Yes.
Now let us see that. And oh God. Sir, have you done the calculation correctly?
That I think so that
Sir,
83,
X2 was given
80.83, it should have
wrong.
been 0.83
It was given in
Wait.
percentage.
percentage.
Wait. What I have typed there? 0.6183. Oh, this is
0.83.
0.83. Correct. Okay, my mistake. 0.8388. Very good. 0.83 this side and 0.61 this side. Now it should come perfectly symmetrical. Oh God.
Sir, it should be 61.86 you have to enter because it is x1 value, no? It is not probability now.
Okay, that is also correct. Okay, you're right.
Should be 61 and
Correct,
83 actual values.
Correct, sir. Perfect. 61, I should type this side. And here I should type 83. Thanks for correcting me. Very good. So now it will come. I'm also wondering why it's not coming. Okay, this is what I wanted to show all of you. This is what we are trying to understand from the normal distribution curve, isn't it? When we move to the left by 1 standard deviation, move to the right by 1 standard deviation, what is the percentage of the red color area?
68.27.
68.27 in comparison to the total area. If my total area is 100 acres, 68.27 acres will be occupied between mean plus or minus 1 sigma. Can you see that, all of you?
Mm.
This is what, the property of normal distribution. We can now apply it for 2 sigma also. Graph probability distribution. Now come to probability. Okay. Now choose the distribution and mean and standard deviation. Go to the shaded area. Now give the 2 sigma points. Maybe Krishnan, can you help me with the 2 sigma points? Mean minus 2 standard deviation. See, we can.
72.87.
How much, sir?
1 minute, sir. The lower point is 50.85
Okay. Then upper side
and upper is 94.89.
94.89. So I have given this and plus or minus 2 sigma this time, right? I give okay. And now what is the coming here? All of you? What is the
95.45.
percentage coming here?
95.45.
So very good. So this is our thumb rule. This is our thumb rule for decision making. Now just forget about the pulse and everything. Forget about the pulse. Let us go to same thing. Probability distribution plot, view probability. Okay. Now let us assume the average mark scored by the black belts. Average mark scored by the black belts is 72. All of you are with me. Now I'm changing the meaning, context. The average mark scored by all of you is 72. I have conducted an exam. I observe too much variation in your marks. Can you see here? 11 means too much variation, isn't it?
Yes.
So 11 marks is the standard deviation. Under these circumstances, I want to understand what is the probability for a student to score pass mark. Good question.
Mhm.
What is the pass mark? Now pass mark means right tail, isn't it? Above certain mark. And now tell me, can you define the pass mark now? What is the pass mark?
Out of 135.
Pass mark, that is 10th, 6th standard, 3rd standard. Now
Mm.
you have come much higher. Now your pass mark is 60.
60.
So what is the probability for a student to score the exam when the class average is 71, class standard deviation is 11. I mean 72 and 11. Let's find out that. I give okay. Now tell me, what is the probability for a student to score pass mark?
86.23.
And percentage seems to be good, isn't it? 86.23% of the participants are safe now. What percentage of the participants are under risk? Maybe 13%. So you are now able to understand your probability of success and hence the probability of failure. Yes or no?
Yeah.
Once this information is available, you can take a decision. And this decision depends on the quality of the data. Am I correct? This decision depends on the quality of the data. More the data, better the quality. And also, you should also be concerned about the sampling. How you conducted the sample test. If you conduct the sample test similar to the final test, then your prediction will be much better. Yes or no? If your sample test is not a representative of the final test, then there will be mismatching. All of you are with me?
Yes.
That's why sampling technique is important and data accuracy is important. This is how we are going to use data for decision making. Let's play with this now. Once you have this knowledge and a way to find out the probability, you can play. Let's see here. Graph. Probability distribution plot. View probability. Okay. Now go to shaded area. Now let's play. As I told, shall we now find out what is the chance for someone to score above 90%? Just type 90 here and give okay. And now how much is the chance for someone to score above 90%?
5%.
Only 5.08%. If you score above 90, now you are on the top 5%. All of you understand how we use this knowledge? And now what is the probability for someone score between two values? And you can decide. I want to know what is my chance for me to score from 60 to 100. It sounds good, right? This is what we want to know exactly. Am I correct or not?
Yeah.
That
This is what
we
all of
are-
us are interested, right? Yeah. So now let's give a thought. Now we have 85%. We already predicted this.
85%.
Now, in order to have a better prediction, what I suggest is, I suggest all of you to write a mock exam. Correct? All of you write a mock exam and calculate the average, calculate the standard deviation. Then you will have a better decision in your hand. What percentage of the students are going to clear the exam and what percentage of the students are likely to fail in the exam. But provided, no, your preparations and everything are, exactly as per the final exam. Clear, all of you?
Yes.
So before we close for the day, let me change this example so that you can connect it to your work. Graph, probability distribution plot, view probability. Okay. Now I produce a rod. The length of the rod must be 72 mm. Length of the rod must be 72 mm plus or minus. Customer has given me a tolerance. I don't know. Let's say 72 mm plus or minus 0.5. This is customer requirement. Now I have collected data from my, process. I went to that particular location or the manufacturing plant where the shafts are produced and the length is recorded. Length is recorded for 90 samples, whatever we have. The 90 sample tells me that the average is how much? 72 mm. What is customer target? Tell me, customer target is how much?
Plus or minus
71.5 to 72.5.
Customer target is also 72.
72.
70.
Target is 72.
72. Okay, wow. 72 plus or minus 0.5 is the customer specification. So customer target is 72 and your process is also centered perfectly. Now you are holding the gun correctly. You remember our discussion? I told you, when you want to hit the target, then you should hold the gun correctly. Whether that is happening or not, we are seeing it, through the sample. And now, do you think this much standard deviation will make you win the race? I mean, win the competition, win the business? Definitely no. Customer has given a very thin tolerance, plus or minus 0.5. So your standard deviation should be in There's no small decimals, isn't it? Not like a whole number. Now let me give some value, maybe 0.2. Tell me, are you really running a process with the highest? Customer has given how much tolerance given on the right side? 0.5 on the right side, 0.5 on the left,
Okay,
isn't
the
it?
left side. Yeah.
But unfortunately, your process standard deviation is like this. Anyway, no problem. Let's find out. Shaded area. And now let's find out what is your lower spec? 71.5. Huh?
Yes, sir.
What is your upper spec?
72.5. 92.5.
Now, what percentage of your rods are going to have length between 71.5 and 72.5? Give, okay. Tell me, what percentage of your
98.76.
rods? 98.76. If you produce 1,000 rods, how many rods will be within the spec?
987.
And 13 will get rejected. But you have not produced 1,000. How many you have produced? Only 92 or 90 or 95, isn't it? With
90
just
samples.
90, 95 samples, you can now understand what will happen if you produce a big number. Yes or no? Do you understand how statistics is helping you? The data not only represents the characteristics of the 90 rods you produced. If you try to understand the characteristics of the 90 samples you produced, then it is descriptive. But with the help of the 90 samples, if you try to understand what will happen to your 1,000 rods which you are going to produce with the same setting, then it is
Friendship.
inferential. But the quality of the decision definitely depends on the quality of your sample data. Yes or no?
Yes.
So the process, first of all, the assumption is the process will run in the same fashion. The assumption is the process will run in the same fashion. No major change. Another assumption is data is clean, free from error. Data is clean, free from error. Another assumption is the person who is collecting the data has some knowledge about how to take the sample. Then this prediction will definitely can receive appreciation. And you can make changes if you are not happy with this, kind of inference. You can make changes. Try to improve the process. Ask your team till they really come to the expected level. Let me show you something. Graph, probability distribution plot, view probability. Okay. Now you improved. And your team has reduced the standard deviation. Can you see a small reduction in the standard deviation now? Earlier it was 0.1.
0.2. Now it is 0.1.
Earlier it was 0.2. Now it is 0.15. Some improvement. Your team has really improved now. Can you believe? It's not orally, they are telling that, yes, sir, we are improving. They actually improved. How do you know now?
It has come
From
down.
the
What is the confirmation here? With the reduction in the standard deviation. When the standard deviation goes down, it's an indication of their consistency going up. At the same time, their targeting is perfect. That's very, very important. Foremost, targeting has to be very, very important. Right? So the targeting is perfect. Consistency is perfect. Now good things should happen. Right?
yes.
You landed in a right form for your Six Sigma learning, and you're also committed. Now the results are for sure, isn't it? Something similar to that. So I just go to shaded area. Now with this improved condition, I want to find out what will happen with respect to the customer spec. Shall we see that now?
Yes, sir.
Okay. Now you produce 1,000 rods. How many rods will get
999.
accepted? Oh,
999.
999. Much better, isn't it? Much
999.
better. Much better. 999 rods will be within the spec. And maybe still you have, one rod which can go out of spec. This is your prediction and art of decision making. Based on the probability, you take decision. isn't it? All right. So this is how you can now, whatever is the value you keep changing. It can give the probability. All that based on the knowledge of the normal distribution. The theory behind normal distribution is used to develop the graphs and show you the numbers. And this is done by Minitab software, a kind of artificial intelligence, isn't it? You don't have to struggle a lot. Now this software can do the job for you. We call it artificial intelligence. Perfect. And now the numbers can be the diameter of the rods, length of the rods, or it can be surface finish, or it can be some number which can represent your team's performance. Which can represent your team's performance, whatever it is. You can plot the cycle time of a particular process, right? The lead time, isn't it? Or the but one important thing is your data must be measurable data. Your data must be
Measurable.
measurable. Because when it is measurable, the quality of the data is better. And so all these theories, can be correlated. You can take decision with the help of the normal distribution. Hope you got some insights about normal distribution with the kind of examples we had. And for some of you, it might look slightly overdose, but definitely this is required. This is not something on the higher side. This is the basics, what we learned. Once we have the data, once we have the average, once we have the standard deviation, we can predict what will happen to our individual samples. What will happen to our individual samples? In order to predict what will happen to our individual samples or individual units we produce, we use this rule. What are the statistics we used? One is average, other one is standard deviation. Once you know the average and the standard deviation, you can understand what will happen to your individual outputs. But instead of average and standard deviation, particularly instead of standard deviation, if you use standard error, you can predict what will happen to your average. The situations are different. The first situation is what will happen to my individual outputs? What will happen to the individual participants' exam mark? That is one question. Another question is what will happen to the class average? Do you understand the difference, all of you? Sometimes I want to maintain a healthier class average. Sometimes I want to make sure every individual student achieves a healthier score. Isn't it? So, depending on that, you can use either standard deviation or standard error. But using standard error is more accurate. Predictions will be more accurate than relying on individual data. All of you agree with me? Earlier you told me which is a better which is more accurate. You all told me, sir, predicting average is more accurate. So, if you are relying on individual data, that means individual data for your prediction, that means you are working with the samples. If you are using individual data for your prediction, you are working with samples. But instead of predicting, instead of making your prediction based on individual data, you can also make your predictions based on average. Sample data is different, sample average is different. Do you understand? If I take 100 samples and then simply visualize and make a prediction, my prediction is based on sample data. There is another way. I don't take 100 sample and then do it. Every time I take 10 sample. Every time I take 10 sample. Every time I take a sample, how many units I am picking? 10 units.
10.
Now I can calculate average. My first sample average is ready. Another time I take the sample. Again 10 units. My second sample average is ready. Do you understand, all of you? Likewise, take the required number of sample average. Once you are happy with the number of sample average you have, make your prediction. This time you will be more accurate. Both the time you are using your knowledge on normal distribution only. But first time, your interval will be wider. But second time, your interval will be narrower. People will start appreciating you. Yes or no? Standard error will be lower than standard deviation. Because what is the formula? Standard error equal to standard deviation divided by something. Yes or no?
Square root of sample size.
So standard error will be a smaller value than the standard deviation. So always taking decision with the help of the sample average is a better way of decision making, better way of prediction. Your interval will be narrower. At the same time, your confidence level, will be as required, 95% or whatever. Clear, all of you? There are two situations I have explained you. One situation working with sample, other situation working with sample averages. We clearly understood working with sample averages a better, better way of decision making. Clear? This is what central limit theorem. This is what is known as central limit theorem. What is this known as? Central limit theorem. Central limit theorem is telling you that the distribution of sample averages will be perfect normal. What is central limit theorem is telling? The distribution of sample averages will be a perfect normal provided sample size is sufficient. Can one of you repeat this central limit theorem?
Distribution of sample averages will be a perfect normal provided the sample sizes are sufficient. Provided
Very
the
good.
sample sizes.
Only one condition. Provided sample size is sufficient. Sample size normally vary from 2 to 25. Vary from 2 to 25. Just take samples, let's say 2 samples every time, and try to plot a histogram. Just see whether it is coming normal or not. If it is not coming normal, you increase the sample size from 2 to 3, or 3 to 4, or 4 to 5. Maximum is 25. You will start seeing your histogram becoming a smooth bell curve. And then start taking decisions. Whatever decision you take by looking at the graph and whatever we discussed so far, same thing you will start seeing happening in your shop floor also. Very, very closer to your prediction, things will happen. Do you think such a scenario will be very helpful for you?
Yes.
Yes or no?
Yes.
That's why you all must study statistics. And I think I have taught you something useful today in this session.
Okay.
This completes my part. Any question anybody would like to ask? All of you, please tell me whether you learned something today here in this
Sir, one
particular
doubt.
session. Yes, please.
Sir, to continue on your that mean and standard deviation one, where you said that project where the sample size will be 72. So what happens if the mean is something lesser or maybe higher? What happens if the mean is 71.8? How do we infer data from that?
Yeah. If your mean is not on the target, that means your process is shifted. Process is shifted.
Okay.
Target is 72, but your process is operating at 65. I asked you to come for the session at 8 o'clock, but you came at 9 o'clock. What happened? You have not understood, isn't it? You have not understood the requirement. And you are not running the process equivalent to the requirement. Requirement is you need to be in the meeting by 8 o'clock. But unfortunately, you joined the meeting at 9 o'clock. Now, definitely there will be a damage. Yes or no?
Yes, sir.
If your mean is not on the target, there is going to be a damage expected. Provided, customer is not, very liberal with the tolerance. Provided customer is not very liberal with the tolerance. but definitely there will be damage in the quality of the product. So always try to keep your process or run your process right on the target. How do we know? By looking at the average. The average has to be on the target with higher level of consistency or lower level of variation. So in order to measure variation, we use standard deviation. And controlling average is definitely a better way or a far superior way than controlling individual values. Correct? Controlling the average is far superior way than controlling the individual observation. You really have to have effective control plan to keep your averages under control. You understand?
Yes, sir.
Making individual students scoring is one thing. And making the class average within the preferred range means, you really have to have a higher order of control. Isn't it? Only when I have a higher order of control. You see here now, how many people are attending the session? Tell me,
Now
how many
8.
people are attending the session? Only 6
6.
people. But what is the batch size? 20 or 25? Under this situation, how can I control the average? Very challenging, isn't it? Yes or no?
Yes.
So if you really want to see your average under control in the preferred region, you really have to have an effective control plan. Then only average will stay in control. At the same time, if the average itself is deviating a lot, that's a very strong signal, something really, bad happening. Too many people not attending the session is a strong signal for me. Yes or no? Too many
Yes.
people not attending the session means it's a strong signal. I don't know how they will manage. I'm not very sure whether all of them can manage this, without participating in the meeting. So that's the reason why I decided to record it. And probably I'll try to share some recordings by publishing the same thing in my channel as a supplementary knowledge. Thank you very much, all of you, for your time, participation, and fantastic interaction. We'll be meeting this weekend again, Saturday, Sunday. Okay?
Sir, only one question, because we did a
Please.
lot of things with Minitab. So when will we, what is the procedure
Right.
for?
Good, great. So what I do is I'll post a link today in the WhatsApp group, and using which you will be able to install Minitab in your laptop. And that's only a trial version, which will
Okay.
work for 30 days.
30 days.
And that is quite sufficient for our learning. You can also do the same from your side also. Directly you can download from internet. Particularly if you have Mac or the Apple laptop on your side, it is better to download directly from the site. But for Windows, yes, you can do it from the internet also, or I will be sharing a link. So that's how you can install. And then you can practice a similar thing. And try to put some time, spend some time on your own to understand the normal distribution, which is the foundation for all the tools. Okay.
Right.
All right. And this particular recording also, I'll put it in the channel and then share the link with all of you. Okay. Thank you.
Thank you,
Bye-bye.
sir. Thank you
Thank
very
you,
much.
sir.
Good night.
Okay, sir.
Good night.
Thank
Bye.
you.
Good night, sir.
Good night.